we are online. I understand, and then we are starting the webinar. Uh, uh, Please keep your microphones off if you don't speak. And actually, a warm welcome to all the participants of the webinar of today. We are covering a very interesting subject regarding the availability of solar power and the preparation of the path for zero emission birthing and the overall the power compliance. How we do it today? We have invited four distinguished presenters, three of them representing correspondent ports in North Europe, Central, Mid Europe, and South Europe, and one representative of a product integrator, product maker at the field. We will be running individual presentations, including the one of mine, and between the presentations, we will allow some questions, the most urgent ones, and we will running a survey poll, and at the end, there will be, we hope, at least 15 to 20 minutes of overall discussion and asking questions from the audience. Now, regarding questions from the audience, we are encouraging you to ask questions at any time. You can write the questions at the Q&A part of the you see on the screen. We try to answer as quickly as possible, either between the presentations verbally, or we provide a written answer. You find the answer on the screen, or if there are questions that we are not able to answer, we are promising to provide an answer in the coming day separately to those requesting the information. And I mentioned the polls between the presentations. So this is the way that we will be running this today. And I start with the first presentation, which is actually allow me a second to find it. Share content, share presentation, and share files, share screen, window, yes, share, and then we put it full screen. I hope that you see my presentation. There are quite a few open questions on the subject, which are requiring simple answers. We see if we are able to provide the answers to the audience following us today. The questions cover various subjects like where we are with the legislation, the regulations. There are regional approaches in Europe and in quite a few other places in the world. The types of vessels covered, technologies allowed, the time horizon of onshore power supply, availability at the ports is a key issue. Are solutions compatible? The solutions provided by the various ports, are they compatible with the various vessels visiting your harbors? The cost of infrastructure, the operational cost of the system, the cost of electricity use, and of course, the last but not least, we are doing it for environmental benefits. Is it really going to help the environment? And again, personally, since I've been involved for 25 years in energy saving, I see the onshore power supply as part of the overall picture. So you have the shipping industry, and you need to optimize operations, reduce vessel energy need, improve the power distribution of the vessel, and create efficient energy, generate the energy efficiently. So there are quite a few actions. And in this frame, one of the actions is the use of onshore power supply. And we see how this is going to help. Again, I'm trying to present the overall approach. You have the shipping industry at the middle. You have the forces which are impacting it, including the regulations and the way to improve the environment. You have solutions. Among the solutions, let us not forget we have the fuel flexibility. We have the electrification, and in the electrification, there is the shore power systems involved. But it is the overall picture that we cannot forget. So it is a part of the whole puzzle. Shore power systems is a part of the overall puzzle. Are there any maritime legislative actions? Yes. Are they covering other countries than Europe? Yes. So there are already requirements in the US, in China, in Norway, and in quite a few other countries, including Singapore, UK, Australia, New Zealand, Canada, South Korea. Some of them are non-mandatory rules, but still the subject is under discussion on a global way. And from our side, since we are focusing our attention in Europe, so we have 3 European ports today. I'm mentioning the environmental proposals, the environmental legislation from the EU Fit for 55 package, including the alternative fuels infrastructure regulation, which cover the supply in ports, Fuel EU Maritime and EU Emission Trading System (ETS), covering primarily the demand, and the Energy Taxation Directive. All of them dictate that by 2030, selected ports in Europe at the Trans-European Transport Network need to be ready for onshore power, covering the vessels, covering the container ships and passenger vessels, ferries above 5,000 gross tonnage. And the expectation is that by 2035, there will be an extension to other European ports and to the other types of vessels. So in principle, it will cover the whole shipping sector, and it will happen in steps. When we talk about the water fleet fuel consumption, some information from the open literature indicates that the fuel consumption at the port covers both use of auxiliary engines and boilers. So the onshore power supply helps to replace the auxiliary engines, which will remain off in operation, and providing some data. The fuel, the total yearly fuel consumption is about 220 million tons, and the total yearly fleet fuel consumption at the ports is about 4 or 5% of the total amount. So we need to put things at a given order. That yes, it is a significant energy reduction. It helps the local environment, but it needs to be seen as part of the overall action for the improvement of the shipping sector, better environmental performance of the shipping sector. And again, I need to say the importance of the integration. There are systems required on the ground at the port. There are systems required on board of the vessel, and this need to be able to work together. And this integration, the engineering efforts to have the correct interfacing is of paramount importance. The cost of electricity is something which will be discussed at the meeting of today. The numbers here are in euro per kilowatt hour, in euro per megawatt hour. You need to see that the numbers need to be say you need to multiply by 1,000. You see actually that the price offered is higher than the price represented by the blue line at the middle, which corresponds to the indicative cost of marine liquid fuel. So if we see from this point of view, we can say that the electricity is costing money, but there is a but, and this is explained in the slide, in the following slide, where actually you see that for a period of 15 years, and taking into account the penalties introduced by EU ETS, by the penalty costs which are added to the cost of the fuel. At the end, the solution for the ship owner is quite the improvement is quite significant. So for the ship owner, it's not only that it is good for the environment, but it's also having the economics working positively. We need also to say, and it's coming in the paragraph at the right side of the slide, there is a possibility that alternative zero emission technologies can be used in lieu of shore power. So if you have batteries, or if you have zero emission fuels, but the current expectation is that the dominant compliance pathway will be through shore power. It's not a surprise if we see that in 2026, from the new built vessels in 2026, 60% of the container ships and 50% of the cruise ships, these are approximate numbers, these new built vessels are already equipped with the systems on board of the vessel to allow shore power connection. So the challenge is for the ports really is a big challenge to provide the power required, which I mean is the regulatory readiness, which is required in parallel to the infrastructure and grid readiness, commercial aspects, the funding readiness. Of course, the harbors, each of them individually will analyze the demand, types of vessels visiting, power required for individual vessels, and then make the plans for the deployment of the systems on the port and the operational integration. Last but not least, the system, the power supply needs to be seen as part of the overall plan, not only for the ports but also for the shipping industry, for decarbonization, and this needs to be also connected, aligned with introduction of zero carbon or low carbon fuels, and electrification and digitalization are going in parallel. So this is the introduction from my side. I'm closing the presentation, and I'm going to. I see myself on the screen now, and I'm a little bit frightened from what I see. I will be running the first polls. So I'm asking the colleague who is helping on the polls to put the first polls on the screen, which is covering the question to the audience: what is the primary driver for your organization to consider solar power? Is the regulatory compliance, the emission reduction targets? Is originated by the customer or the charterer? Are there any specific port incentives and reduced payments, reduced fees, or the primary driver is a corporate sustainability target? We collect your answers, and we will be able to discuss this at the general discussion at the end of the presentations. And then I give the floor to Mr. Hanno Bromeis from the Port of Hamburg for his introduction. So, Mr. Hanno, the floor is yours.
Yes, thank you very much. So, trying to upload. Let's see if that works. So, yes, thank you very much for inviting me to the panel. I wanted to show you a little bit our view on the road to zero emission. I hope everyone can see my screen, otherwise please let me know. In the Port of Hamburg, we've started our journey quite some time, and this is basically our roadmap on this road to zero emission. We want to be a carbon neutral port by 2040, and we basically divided that into four-year phases, basically across the different vessel types. The electrification is the main activity, but we also want to make sure alternative fuels are available in the port. And we focus in terms of the deep sea vessels on the large container berths and the cruise berths, and we'll continue with the feeder segment and the ro-ro. So this whole is driven by the regulation on one hand, but then obviously also on the technical availability on the user side. That basically was driving our priorities. So let's take a little closer look in terms of what we have done. We've basically this Port of Hamburg is a city port, basically. For those who are not familiar with our geography, we are right in the city center. The city is around the port area. Therefore, environmental aspects are a critical issue in our port. So that's why we started really early on in 2010 with the first shore power facility development project. And it was also now open in 2016, directly adjacent here on the northern side, 12 MVA facility. And then we completed the two other cruise terminals last year and the year before. So 14 and 16 MVA facilities. And we also completed the 4 facilities at the 4 container terminals we have, the large birthplaces. We've started there, and they're all live now this year. So having come quite a way already on that. Just to give you a bit of an overview in terms of the challenges and how we actually solve that. Typically in the container birthplaces, you have not much space, and so it's very confined. And also you need to decide in terms of where to build your facility. At the time we started, we hadn't had any blueprints. There was only the US at the time available, and they only had pit boxes as connection systems, and that didn't prove really suitable for us. We needed something more flexible because we have flexible mooring patterns. So we actually investigated the suitable service areas based on where the cable was to be expected to come down on the large vessels, those 1, 2, 3, the yellow that you can see here, and then designing a flexible system. You can see here basically the quay wall. There was not much space, and as an additional complication, we have a flood wall because we are a tidal port. So the only way to install a system was to put it on high rail on top of that flood wall, so movable system sliding along the way here. And this is basically how you can see it in operation along the quay wall. This is the vessel side on the left-hand side. And the system then goes into the position. It can be lowered to the quay wall level. Then the connection can be made and it's raised up again so you can walk underneath freely here. So that's basically our solution to make use of the space that we actually had. At another terminal, we had an even bigger challenge. This is now the Burkard Kai, the opposite of the basin. There, you can see here in the middle, we had the leg of the container bridge on the other side of the flood wall, so there was no option to put it places on top of the flood wall. The only solution here was to attach the system to the front of the quay wall. So you see these yellow rails here that were attached, and there's a sled, that connection system that moves along those yellow lines. Again, those three areas for service identified for this 7.5 MVA connection we were filling in there. And here's a close-up. You can see this in operation. Again, this connection system goes into position, folds down, so you can make the connection, and then when the connection is secured, then it folds back up again, and then the container bridge can pass freely underneath. So those are the two basic facility types that we have in the container segment. All was needed to build during operations, so also a big challenge to get that done. We also have cruise, as mentioned. That's a classical layout. On the left-hand side, you can see our first facility, the Altona pilot in 2016, really looks also like a pilot. And ever since then, the industry has evolved, and we're building more like the classical types of vehicles that you can see in the middle and on the right. Classical Steinwerder and Hafen City, the vehicles that are, in our case, permanently connected to cable trench and then drive along the quay wall to get into the position. So that allows us to have like a minimal footprint on the quay wall, because there's no cables lying around on that. Yeah, so that's basically just a quick overview in terms of what we've done, but also we are not finished, as mentioned. If we go back to our little map again, I mean, we've got the 3 cruise terminals, so they're all cruise terminals, so we don't need to do anything there. In terms of the container terminals, it has been the focus to build facilities at the large berth places. So what's now coming is the short sea to connect for the feeder vessels. And we have another RoRo terminal that we are currently planning and starting to build next year, the Oswald Kai in that area. In terms of the short sea, there was for long the discussion about what voltage should it be. We will have only high voltage for the short sea segment also. So it's and the other because we wanted to ensure the interoperability across the different ports. So just one single system, high voltage throughout, as the norm is actually prescribing. The challenge on the short sea is obviously the length of stay is much shorter, so therefore things like making the connection is much more, needs to be really efficient, because otherwise the whole shore power is pretty futile, because like on average a short sea vessel stays 12, 13, 14 hours in the port, sometimes across different terminals, so really efficiency is critical. The mooring pattern is much more challenging, because they are not so, like the large vessels, they always moor in the same spot. Not so with the feeder vessels, sometimes reversed on the other side. So there again, you need even more flexibility in terms of the connection system, so more variability. And what's also a big challenge is that the freeboard is much lower. So sometimes you have a negative incline with your cables. Also, that needs to be taken into account. And then obviously the whole question about the propulsion of the future. What are we expecting? What's the uptake of shore power? What's the uptake of battery propulsion maybe? Because that then, we also are and will supply the battery charging through our shore power facilities. It's the question in terms of how much power we actually need and when do we need it. And therefore it's critical to know what the uptake is going to be. So that a little overview in terms of where we are. I don't really go into the other segment, but again, I mean, by 2030 we try to be compliant. Maybe we depends a little bit on the funding. Obviously, we will know towards the middle of the year if we get all our funding closed so that we meet the 2030 target. Otherwise, basically all the other segments in the port will then follow after. Some issues in terms of on the commercial side, because building is one big challenge, operating is the other. How are we doing it here in the Port of Hamburg? We've decided to operate facilities ourselves, so that's the first thing you also need to decide. I mean, who's actually operating it? Do you delegate that to somebody? Do it yourself? At the moment, we have individual contracts with the shipping companies because it's just individual companies at the moment. But going forward, we will then also integrate all these the aspects, the contractual aspects, into the general port's terms and conditions. It's not the case yet, but come 2030, we're definitely going to do that. The energy is from the spot market because at the moment we still only have spikes of demand, so you can't really secure that by PPAs or something like that. So that's also something to bear in mind. Where do you get the energy from? It's 100% green, although obviously shore power by definition is green according to the European Union, but we still also buy certificates. So there again, we have another different pricing component. What is the price of the certificates? You need to take that into account. Obviously, another big issue is the handling, the connection personnel. Where do you get that from, and how do you efficiently can deploy that? Especially in the container segment, you will have not a very reliable ETAs, ETD plan, so that's a big challenge to have that in an efficient way. Your personnel there ready at the quay wall. Cruise is a much easier segment because it's much more reliable in terms of when the vessels are to be expected. Now, thinking about, do you do your own resources? Do you again have external resources? What capabilities do you have in place? We do the invoicing ourselves as HPA, so the whole invoicing and issue is obviously something where digitalization will be really critical. For now, we only have hundreds of calls, but come 2030, when the regulation kicks in, we'll have like 6,000 plus calls. So therefore, it's definitely a critical aspect to have a very efficient way of how to deal with the invoicing until then. So currently building this digital solution on that. Connecting, sure, everybody is supposed to be compliant with the 80,005-1 norm, but still, then you need to have the compatibility assessment with the vessels. Many vessels that are coming to Hamburg, they connect the first time around, so it's an issue to have those first time procedures, etc. So also makes connections much longer than actually regular processes. So probably for many ports, not a big issue. For us, we need to develop that learning. Very often also the crews are not experienced on the vessel side. So sometimes also, and we highly recommend that the liner companies that are not so experienced hire some external resources to help them to steer through that process. That certainly helps a lot. Sometimes you have certifications, they are then actually, they're not valid anymore because it has been too long time that the vessel has taken shore power. All these issues, they're particularly challenging in a pre-2030 situation where it's not a routine process in every port yet. So we have built the capabilities. We are supporting the container vessel operators in the process in order to get these certifications and to get a stable process and to develop that learning. So just a quick aspect also on the business case. That's also like a big challenge, especially like prior 2030. What is the pricing structure that we are following? We have two component energy price plus a service fee. Energy prices from the spot market, and the service fee basically covers the handling and the OPEX charge. At the moment, we don't really make a margin on this. We just want to basically cover our cost. And at the moment, obviously, with this is actually fixed cost. So at the moment, the utilization will go up, fixed costs will come down. And later on, when we have more feeder vessels, then obviously it's also probably a better idea to have some of the OPEX put onto the kilowatt price in order to make it feasible for feeder vessels also to connect. So those are basically our thinking on the pricing. In order to get some stability on the planning, we actually do like a previous month average on the electricity price, so that you're not totally exposed to the spot market volatility. Yeah, so to wrap it all up, we have come quite a way, and after building comes operating, I would say. Building has big challenges, operating even more challenges. And as we need to do this short sea segment, yet more challenges on that level. We very much hope that the regulatory environment stays firm. I mean, if we would be watered down, would be a big setback in terms of on the business case. The classical challenge for everybody around the funding, the grid, and the technology. Funding, we were lucky to have a lot of funding. We will see whether everything will be funded by the mid of the year. Grid is, we were quite lucky here in Hamburg because we're an industrial port, so it's a strong port. But still also we need to strengthen the grid. So it's a process step by step, especially if we were to expect more battery powered feeder vessels. We certainly also need more power and more investment into the grid. Technology will be probably a big challenge because if all the ports are building towards 2030, I would expect that the lead times will go up, prices will go up. As mentioned before, the business case right now is very difficult because it's very expensive, only few connections. So after 2030 will be much more feasible to cover your cost. Involving the terminal is a big challenge to watch out for. In our case, we were doing it ourselves, so terminals hadn't really had a stake in there. That's a bit of an issue, how to involve them, because you actually clearly are in conflict with their operations. The efficiency of the operations, the learning curve, how to deal with your people, how to staff them properly, digitalization is a big challenge that you obviously need to watch out to look for. And at the end of the day, it's all about the growing together with the vessel owners. Shore powers is still a new thing in the industry, learning together, sharing your know-how, and just when you do it the first time around, it's a learning phase, so you'll get better over time. So very happy to share our experience. We've come quite a way and very happy to share on that. Thank you.
Well, Hanno, you have received a huge number of questions that I try to bring forward a few of them. Can you hear me? Well, just I'm reading one or two questions from those I am reading at the on the screen, and I start with probably the easiest, the easiest, and then regarding the connection for the feeders, is it low voltage, high voltage?
It's going to be high voltage because that's basically what the norm is going to describe. What the norm has been prescribed, and as a large port with mixed vessel types, like large container vessels, small container vessels, we don't have the options to offer like shore low voltage for feeders. Especially, there's one single system as the norm is prescribing, that's high voltage. And so everybody can charge there. And personally, I would also be expecting that the feeder market is turning into battery electric over the next decades. So and therefore, if you want to talk, if you talk about charging, you need high voltage anyway. So okay. You should get your vessels ready for high voltage. Yeah.
Okay. Then how we are dimensioning the OPS systems in terms of required power, because are all systems for container ships identical? They have the same power. Is there any differentiation? And are we sure that we are covering the requirements of the vessels up to a large size?
Yeah, I mean, by and large, the norm, I mean, for our region or for our port, definitely would require to over-dimension facilities. So how do we solve that? Is that we basically can combine our converters to supply the full 8 MVA per connection if needed. But in reality, we basically split them so that we have actually a much more efficient asset layout in terms of the converters. So we don't have like 8 MVA per connection all the time, but in smaller brackets, because like even the largest vessels that we have here in Hamburg, I mean, they take 2,500 kilowatt, not more. Yeah? So and that's a 20,000 TEU or 24,000 TEU vessel. So therefore, there is definitely a large over-dimensioning. So we budget on 4 MVA per connection that we are going for, and that typically actually is sufficient. Also on the cruise side, the 16 MVA that is required. We don't see any vessels in our port that ever reach that. I mean, 8, 9, 10 is actually the max that we see.
Okay, and then a question from my side regarding the electricity cost structure. By curiosity, is there any action in Europe between the ports to discuss this item and compare how far differs the electricity cost in Hamburg from the electricity cost in Amsterdam or in Barcelona or in Oslo or in Antwerp? Is there any thought, or every single port is offering its own electricity cost structure?
Yes, I mean, electricity markets in Europe are local, so or national at least. So therefore, I mean, every country doesn't have their own electricity regime. So, and if you go to Norway, you've got much more renewables there already. And if you are in Hamburg and in Germany, we are still in the transition to get more to that. So I think you'll never have the same prices across Europe on that. So because you always have local conditions, you've got local taxes and all of these things. Because also the pure electricity component is only a fraction of the electricity price. There's also the grid, the network, and all of these things. And they also depend not only on the national regime, but sometimes also on the local choices you are able to make, how close you are to the substation, or do you have high voltage available, or like the very high voltage available. All these things will drive your effective electricity price. And also in terms of on the other costs, I mean, you will always have not a direct comparison between the ports because labor is different, the maintenance cost is different, etc. So you might have certain conversions, but it's not going to be identical. I think that's not realistic to expect.
Thank you very much. I believe that it's time to move to the next presentation, and then we'll be connected to Mr. Markus Martelin from ABB Marine and Ports. Markus, the floor is yours.
Okay, thank you. Let me share the screen. So you should be seeing my screen. Yes. Yeah. Good morning and afternoon and evening. Evening, everyone. My name is Markus Martelin, and I come from a company called ABB, technology provider, and work in a division called Marine and Ports. ABB has 16 divisions, and Marine and Ports division is focusing on vessel propulsion systems and electrifying the marine industry, and also has a good portfolio for the terminal operations. So starting from the OCR gate systems to crane automation to electrification of the terminals, meaning the distribution of electricity in the ports and electrifying the terminal traffic, and then also we are one of the few companies providing shore power both on the vessel and the terminal side installations, and bundling all this with the services needed. And yeah, there's been already 2 presentations. I could be that there's a little bit of a repetition, but looking at the shore power and the maturity level of the technology, it almost looks like a no-brainer that this is the very good way to cut emissions, both global and local emissions, while the vessel is berthed, and at least as we see, there is still public funding available, and the regulatory framework in Europe is quite solid and makes the shore power commercially viable solution. But then there's also the flip side of things, and I suppose these are very much the topics that we are discussing today. So there is a high capex cost which comes from the civil works and the electrical substations and cablings on the cable management systems on the shore side, and grid capacity from where how we see it is always a question mark when a new project is being started, and I would urge any terminal thinking of this to start really with the grid capacity, because we are competing, of course, with many initiatives which demand electricity in the cities. And once we go for shore power, of course, there's a wish to go for renewable energy, as we are really trying to cut the absolute emissions produced. There are so many stakeholders in this whole equation. You have the DSO, you have the Port Authority, you have the terminal operators, you have the ship owners, ship operators, and trying to make a business case for every stakeholder is a challenge, and of course takes time. And in order to have a business case, you need to utilize your assets. They have to be fully utilized, and that means that both and the ship and the port need to be ready. So it doesn't help if only the other one is ready. We also see there was also in the chat box questions about the different vessel types and how they are covered. We luckily have the IEC standard, which covers most of the vessel types, but we still see differences in some within the same vessel type, like where are the connection hatches of the vessels, and this, like the practical things and the load variations, the profiles of the load when the vessel connects, they also do vary. Then we have the issue with the safety. So you need to have qualified people to deal with the high voltage. Shore power is a specific application where people are touching and dealing with high voltage equipment and cables. So this is a very, I would say, unique application when it comes to electrical systems. Public tenders, of course, we deal a lot with taxpayer money, so it's good to have a firm, fixed and transparent processes, but it also creates quite a lot of slowness in the process and quite a lot of paperwork to deal with. And then last but not least, I guess we all had some hopes for the IMO Net Zero framework, which would kind of then globalize this whole thing. But for the time being, it looks like that this is a very, very slowly moving thing. Then on the shore power itself, the system looks very simple, of course, in a picture like this, but we are in essence connecting two independent electrical systems together. So we have on the shore side, we need to match with the grid, to be compliant with the grid and match the power and the voltage, and also the frequency to the vessel needs. So when we talk about installations in Europe, this frequency conversion from 50 to 60 hertz is practically always needed, which is not the case, for instance, in US. And then the vessel side installations, they do depend on the vessel type. So do we need a transformer to match it with the main switchboard of the ship, or can we connect directly? And the critical piece of this energy chain is really the cable management system, which also has to adapt to the various needs of the vessel types and the available space on the terminal side and so forth. So this is a extremely critical piece of this system. And just for sake of clarity, ABB does not manufacture cable management systems, but we do deal with all the major suppliers and integrate them into our deliveries. And now this IEC standard has been mentioned many times. It's actually a triple standard, so it's also IEC, ISO, and IEEE standard, and covers most of the ship types like the container, ro-ro, Ro-Pax, and cruise vessels, and you see the differences on the vessel side, and also the power levels and the connecting voltages are defined there. The fourth category, which I wanted to lift here, are the hybrid or zero emission battery driven vessels, which are really the wild west of the connections, because there is no strong standard yet in place. And also we do have vessel types which are not covered by the standard yet. We have like the tankers, which most likely will grow as a segment, because California is starting with the CARB regulation also for the tankers. So we expect that segment to grow, and the answer to that is that there will be an IEC annex coming for tankers as well. But if I jump on the hybrid vessels and the short charging, when we really talk about the charging, the landscape is quite how to say, it's quite complex. So if we look at the power demand of different vessel types and the available connection time, we can put the various vessel types in a graph like this, and down at the bottom we can already and we see installations using the EV charging, the CCS standard, or using the LVAC tailored connections, and the very latest development is then the MCS standard, which stands for a megawatt charging system, which is a standard for heavy duty vehicles, mining, and also marine, and there we start to see capabilities to charge with 4 megawatts on DC, and that will cover many of the, let's say, short distance vessels like water buses and tugs and so forth. The most demanding, what I would say, is the Ro-Pax. Most of the new building ferries, they are hybrid. They have large battery systems on board, and they have typically quite short connection times, and that means that we have high power in a very short time, and that sets let's say very demanding outlook for this segment. So here we talk about powers of 50, 60, and even more megawatts per vessel. Going back to short power or short connection, we see that this power levels, of course, they do vary between the vessel types, but for MVA blocks, I can't say it's a industry standard, but it's you see it quite commonly in the specifications from customers, and it for a good reason. So you can cover many ship types like the smaller ferries or ro-ros, smaller container vessels with the 4 MVA system, and then doubling that to 8 MVA, you already cover even the biggest container vessels, and then further scaling up like cruise vessels to 16 or 20 MVA. So with these four 4 MVA units, you are able to then cover majority of the vessel types, and like Hanno was saying that there has to be this optimization or optimal use of the equipment on the shore side. So sometimes in one connection point you need 4 MVA, and sometimes you need 8 MVAs. And the power levels are really described in the standard, which is mentioned on the slide. There's a lot of talk about batteries, not only in ports, but basically in everything nowadays. There's a lot of talk about it, and also in terminals or ports, and I would say that within the last 12 months, the number of inquiries coming, I mean, what we see for battery energy storage on shore has really grown. So there's definitely interest on it, and it's no wonder when looking at, I mean, what kind of features can be provided. I mean, customers look for combining solar systems and wind, and with battery you can really make the best out of the renewable energy. You can also increase the reliability of the whole port electrical infrastructure for short blackouts, and then maybe in the future, most likely we start to see that there could be participation in the energy markets as well, which would be then that you fully utilize the installation also outside of the shore power as such. When it comes to shore power systems and energy storage, I mean, the most common use case is the peak shaving or shifting peaks to a more adequate power level. But batteries can be used for many different purposes, and this is where we typically spend most of the time discussing that what is the actual purpose of the battery. And this is not really just a future thing. It's something that already happens, and we have delivered the Port of Toulon shore power system, which consists of four connection points, 3 for ferries and 1 for cruise connection, providing both 11 and 6.6 kilovolts and both frequencies, and has a decent size of energy storage system as well, which is there to cut the peaks or do the peak shaving from the grid side, and then also make the best use of the photovoltaic energy that is being produced. And so this system is in operation, and I would say that the only kind of next thing what can be developed here is the full system optimization. So kind of considering that which vessel is the next one coming in, what is the estimated load of that one, is the sun shining tomorrow, so should I charge today or later tomorrow? So this type of full or total optimization is very difficult by hand or by a person, so it should be done by an optimization software, and I think that things start to move in that direction in the future. And then last but not least, I wanted to lift the topic of the operations. There's often most of the discussions happen for the initial installation, which is from the lifetime of the installation, it's 1 or 2 years, and then that period is over, and then you might have 40 years of operation, and then it should be, I think, paid more attention that what happens during this operational phase and how the system is supported. Of course, safety, having certified workforce, keeping the systems systems up and running, and being honest, obsolescence management, if you take any PLC or your own laptop that you are now looking, if it's 5 years old, it starts to be already old, and typically in 10-15 years, also these industrial PLCs, they need to be upgraded. So having this kind of visibility that what is the level of obsolescence and tracking that is needed in order to avoid trouble in the future. And also systems can be upgraded, so maybe new features can be added along the way. So then, concluding, shore power solutions exist. There are many installations on ships and on shore, and it's a proven, mature technology. And shore power is quite well standardized. It's not ideal. There was a question about does China and Europe share the same standard? The answer is yes, but it's the standard is not watertight. So there might be details that are like a stone in the shoe with the first connections. Shore charging has a little bit more. It's a not so mature technology, and the standards are not yet in place. But now with this MCS standard, we hope to see some development there as well. From the technology perspective, we see that there will be software, meaning the energy management and the optimization becomes more and more important when we start to deal with huge amounts of energy and power in a terminal. So it has to be somehow better managed. And looking at the whole life cycle of the installation, I think the key things for the business case are selecting the right equipment for the purpose, and optimizing the system level so that the assets can be used to the maximum, and then taking care that the service capabilities are there, whether they are customers' own service capabilities or then somebody else's, but they need to be there. And that concludes my presentation.
Thank you very much, Markus. Excellent presentation, which have raised quite a few questions. I would ask you, please, during the coming minutes, to have a look at the presentations which have been asked during your speech. There is a specific question regarding tankers. How you see the application on tankers, taking into account that if something wrong happens during power supply, then it might ruin a part of the vessel system.
Yeah, that is a great question. There's a lot of discussion around this tanker segments, and like I said, there is no IEC standard yet in place, but there is a guidance from an organization called OCIMF, and the IEC committee works very closely with this association and comes up with the normative annex to the IEC standard. So it will come. There are also very practical and real issues where the connection, how the connection can be made. Is it in the midships or is it in the safe zone in the aft? And our take in ABB is that we want to provide the possibility to connect either in the midship or in the aft. I think there has to be flexibility because the terminals are very different. There has to be this flexibility, and then it's so that's why we have also the ATEX ATEX-proof solution for the tanker vessels. But safety first. I mean, what can I say? It's something that we cannot jeopardize the safety, but that's why we develop the ATEX solutions.
And there is another very interesting question regarding the standards, which differ significantly between China and Europe. And actually, if you have one vessel moving goods from China to Europe, is it able to use the shore power at both sides, in China and in Europe? Is there any compatibility? I mean, of
yeah, well, it should, but I have to admit that I have heard the same thing earlier, that some of the auxiliary sockets have not been matching, and that has caused problems, especially between China and Europe. But the answer is that they should be. So I don't really know where the root cause of that problem has been. And I think it's very much in the container segment, because most of the container vessels are built in China, but I can take an action actually on that, because we sit in the IEC committee, and I can get an answer.
Yes. On the container ships, the cable management system is always on shore, or it is on the vessel.
It's on the vessel. On the cable reel is on the vessel side, and then the receiving end is on the quay side, as Hanno actually had some.
Yes. Okay, thank you. We need to go through the next polls, and then the question is what factor most influences the financial viability of shore power for your fleet? Is the electricity pricing, the port fees and incentives, the fuel savings achieved, the carbon compliance cost, or the capital expenditure for retrofit equipment? Thank you. And then we could ask Mrs. Anna Arevalo Gandal to prepare for her presentation and load the. If it is possible to load your presentation, it would be great.
Good afternoon.
Hello.
Yeah.
The floor is yours. Thank you.
Okay, thank you very much. Thank you very much for inviting me to be here today. It's a real pleasure to share the stage with all of you, and I will try not to repeat some of the things that my colleague has explained before. So let me just start with a question that could be, for example, what does it really take to electrify an entire port? I mean, not just one terminal, but a whole port with all its operational complexity, with the energy demands, with all the stakeholders working together. At the Port of Barcelona, this is the challenge that we decided to take on around 6 years ago. At that time, there was almost no data, very limited experience that fortunately some of our colleagues shared with us, and many unknowns. Today, there are some unknowns, but we know more and more every day. At this moment, we knew one thing that was for sure, that if ports want to play a real role in decarbonization, the OPS was essential to do that. So let me just try to share with you the journey that we have had during these 6 years through our docks electrification plan that we call Nexigen. And I'm trying to focus in 3 aspects. First of all, the strategy. How important is the strategy to grow and to implement the different projects? Secondly, the access. We have spoke about that. The importance of the grid, that is critical. And finally, also share our experience and how our experience has teaching us to do things. To electrify, this shows the strategy of electrify our port. We are a diversified port with several terminals divided more or less in 25 kilometers of docks. And based on our own estimation of vessel consumption, we calculated that we will need around 80 megawatt to electrify the entire port. This amount of energy is very difficult to get overall in a port as our port that, as you can see, is located close to the city of Barcelona. So this first key step was to secure the access to electricity from our national grid. And we aware at that moment that this process was going to be a very, very complex and long administrative process. So we start to do it. We start to speak with our ministry, etc., to get the power. But at the same time, we decide not to wait and moving forward with pilot projects into different areas. One was here in the south of the port, in the Hutchinson terminal, and the other was here in the north part of the port, in the Grimaldi terminal. And this allow us to start learning by doing. And in parallel, trying to build this roadmap to moving forward phase by phase, step by step. Today, the result of this strategy is that we are building the substation port here in the center of our port, and this is the heart of our electrification plan, because with this substation connected to the electrical substation belong to our national grid, we have enough power to electrify the whole port. And the idea is to build a dedicated grid exclusively for dock electrification. So this infrastructure that you are seeing here, it will be the cornerstone of scaling up the OPS in the whole port, in the different phases, as I have told you. But how we are going to do this? Sorry. Well. Let me focus on our best container vessel. This is our first OPS that is located very close to the shore side. This was a key milestone because it represents the first OPS for container vessel at the Mediterranean. And also, as Hanno and Marcus has explained, is 7.5 MVA OPS according to IEC, but also we can split in two. So we can operate 2 vessels simultaneously with the same OPS. So far, in just 18 months, we have completed more than 75 stopovers connected and delivering more than 6 million kilowatt hours. As Hanno has told before, the vessels that we have connected are around 25,000 TEUs, and they are demanding in Barcelona around 2 megawatts on average. And they stay a lot of time in Barcelona, so we have covered more than 3,000 hours of connection. What is more important, we have saved more than 4,200 tons of CO2. So this is for me what is more important, as I have so say. In terms of operation, it's important also to mention that also in our port, around 60% has been first calls. This meaning the commissioning and the preparation of the vessels to do that. As you can see, the data show a clear transition from the pilot phase into the regular operation that we are taking now. And this project has provided us with extremely valuable insights into technical performance, operation coordination, and real vessel energy behavior, and as we can see later. This is the junction boxes that we have on the quay. And now, if we move from containers to ferries, we see a different operational reality. At the Grimaldi ferry terminal, we have already reached more than 230 stopovers connected to OPS. This is because the vessel is the same vessel that came to the port every day and stay in the port around 4 hours. And this resulted in more than 2 million kilowatts hour of energy delivered. And as you can see, around 500 tons of CO2 avoided. In this case, the average power demand is lower, much lower. It's around 766 kilowatts. And also give us a clearer and more realistic picture of the actual consumption patterns, which is, I think so, particularly relevant for the future designs that we are doing now. Compare to container vessels, OPS for ferries is closer to becoming a routine operation, which makes it an excellent environment to consolidate procedures, improve efficiency, and so on. Also, digital improvement, etc. At the same time, I think it's worth to underline that the project has reinforced the importance of close collaboration. That is a thing that also my colleague has mentioned before, because it's just not only the collaboration with the terminal as Invest, but also with all the ship owners, and in this case, as the crew are very involved in the operation, is also the collaboration with the crew is also crucial. Now moving, so these are the two projects that are already in operation, and let me move in to where we are today in terms of building. This is the substation, belongs to the National Grid. This is the substation that we are already building, and we are also doing this project connecting both substations. This is what allow us to arrive in the first moment to this key, that is the key where all our cruise terminals are operating. Here we have 7 connection points for cruises, and we are going to electrify all of them. So imagine the quantity of energy that we need to distribute to this key. At the same time that we are building this substation, we are also build the infrastructure for cruises for the two first connection point, one for the MS Cruise terminal and the other for the Royal Caribbean terminal. Both systems have been designed with the latest technology, all the time aiming to improve operations. For example, in both terminals, we are implementing a cable chain system along the quay with movable connection point. So this will help us to speed up the connection process on the quay. In addition, for example, the CMS will be much more compact, making also the operation easier and making the CMS easier to handle and helping us, hope so, to do the operation faster. These two cruise OPS system will be the first to be connected with the substation that we are building, and will be ready for 2027. So let me move in now. Yes, briefly touch on the investment behind this Nexigen plan. In big numbers, the total investment is estimated around 200 millions to develop the whole project. Out of this, around 64 million are allocated, already allocated on ongoing works which are or executed or under execution. And it's important also to mention that around 30% of these ongoing works are subsidized through European funding programs, which I think is very, very important to have this kind of programs to develop this infrastructure with a high capex as they are. So the financial support is key to accelerating the implementation of this kind of projects. Let me finish with some key lessons learned from operation, which are very relevant. One of the most interesting findings is that the current energy consumption is lower than expected. And this has a lot of implications for infrastructure sizing, for business models, for planning assumption. But I think that also is a good opportunity because allow us to optimize future design. And it's important to put on the table that we should make we should share data from ship owners, because this information is essential to improve planning and to reduce the uncertainty that we have when we design. So ideally, we should move towards an harmonized and publicly accessible database, which can support more consistent and more efficient the OPS deployment worldwide. I think this is clearly very, very important. Regarding other main lesson learned has been the coordination. The coordination between ship and shore is particularly challenging because vessel arrival times are often uncertain, and operation in case of container ship, operation depends on port logistic and potential delays. So in this case of container in particular, schedule are not always predictables, which means that operation teams must closely monitor vessel movement in order to be ready when the ship finally arrives at the port, etc., etc. And this is very cost in terms of operations. So depending on the segment, container highly variable, ferries is more stable, but still operational sensitive because the short time they spend on the dock.
Mrs. Anna, we need to close.
It's the last one.
Thank you.
Yeah, sorry. The last one is just moving again, yes, through the digitalization. I think that is Marcus has also mentioned that. It's essential is to establish digitalization between the shore and the vessel. Thank you very much. I'm sorry if I spend more time than.
Thank you. Actually, I would like to ask you to have a look at the questions and answers. There might be some questions related to.
Okay, I can try to answer during the.
And I'm going through the last polls, the question which is remaining, and it is related the time expectation that the shore power can become standard practice for most commercial vessels calling at major ports. So there are 5 possible answers to the question. You can read it already happening today, or within 3 years, within 5 years, within 10 years, or longer than 10 years away. Please, if possible, provide an answer. And at the same time, we would ask Mr. Jens Erik to prepare his presentation. Thank you. And Jens Erik, at the time that you are ready, the floor is yours.
Yes, thanks. Good morning and afternoon. I think people are from all around. I will share. My name is Jens. I'm head of energy transition in the Port of Oslo. And I will share 5 lessons from our journey towards zero emission port and shore power compliance. They come from a project that has worked quite well and projects that have been more challenging. And they come from learning along the way. First of all, Port of Oslo is Norway's largest public and passenger port. You can reach, it's quite close to the city center. We have the city port in the city, and then we have the cargo port just 5 kilometers from the city. So from Oslo, you can reach half of Norway's population within 3 hours. And that also is an important point of having a port in the city, is that you can move the goods as efficiently as you can with sea transport, as close to the customers as possible. Our vision is to become the world's most efficient and environmentally friendly city port. And we already have electric ferries. All the local ferries are electric. We have workboats, service vessels in operation, as you can see in this picture. And as you also can see, is that I think this is the world's first electric boat parade. But I'm happy to be corrected on that. So you can kind of see some of the vessels we have in our port, but also the leisure crafts and also local ferries in the port harbor area. The city and the port has a common action plan, and that is to reduce the emissions by 85% within 2030. Our emissions in the port is quite small compared to all the other emissions in the city, but we play an important role in enabling other sectors to reduce their emissions. By, for example, now we are building a carbon capture plant for waste incineration in the city, and that CO2 will be transported from the port. And also reducing road traffic into the city, and also supplying building materials to the many building sites in the city, only 5 kilometers from the port. What makes our climate target even more ambitious is that we include a transit area of 7 nautical miles from the port. So when I come into the emissions data later, I will show you how shore power what kind of emission reductions we will get with shore power. In our own organization in the Port of Oslo, we have reduced emissions by 99% since 2017. So the real challenge now is not inside the organization, but helping. It's about reducing emissions from the ships, from the industry in the port, and transport in and out from the port on the land side. So our first lesson back in 2017 is that you have to start with really good emission data. When we started in 2017, we didn't have a complete overview of the emissions occurring in the port. So we began collecting emissions data, and that gave us a clear picture of where the emission occurs. And we saw that about 65% of the emissions occur in the port while ships are in port or during cargo handling. And that means that we can reduce 65% with shore power and with electrifying the cargo handling, electrifying the vertical equipment, the horizontal equipment, and so forth. So that was an important realization. And we report back to the city actually 3 times a year and our progress of reducing emissions. And so far, we have reduced emissions by 34% since 2017. And that is at the same time, you can see that, for example, cruise has increased quite a lot at the same time. So that is something that is we're getting some new OPS systems for right now. Having good emission data also give you a quite good confidence on where to invest first. Our second lesson is building before demand. We started quite early before we got these regulations from AFIR. So back in 2018, we started our first OPS based on the international standard for ro-ro ferries. I remember back then the chicken and the egg dilemma. Should ports build first, or should ship owners commit first? So back in 2018, we decided to build first. And it didn't feel like an easy decision right back then. None of the ships committed to using shore power. And you could also read headlines in the newspapers saying that Port of Oslo is spending millions on shore power that no one will use. And to be honest, at that time, we could not guarantee that the media was right or wrong. But during the process, after quite long in the building period, maybe some political pressure, some unpleasant headlines, ship owners started to commit. And the ships have been connected ever since. And what we have learned is that infrastructure can create demand. Of course, it's helpful with regulations, but with the lack of regulations, this has been a lesson from our side. And following that, we built shore power based on low voltage standards for the cement carriers. Cement carriers have quite a high energy consumption in the port. They use a lot of power transferring cement up in tall silos. We also have built OPS for bulk ships. In 2024, we built a shore power system for cruise vessels on one of our cruise quays. We got a full electric tug in 2024. And this year we are finishing another shore power system for cruise at another quay at Filipstad. We're working, we mentioned earlier on, Marcus mentioned tankers. That is a project we are working on. Gothenburg, they have built, Port of Gothenburg has built shore power for tankers. That is a project that we are trying to learn a lot from. And also we will have shore power for Northern Lights, which is a CO2 carrier finished next year. That will be based on the low voltage standard. And then in 2028, we will also have a OPS for containers on high voltage and low voltage. Lesson 3 is about business models and incentives. A key question for us is how to avoid punishing the first movers. So we introduced a zero emission fee that everyone pays. All the ships that come to us pay a zero emission fee per gross ton. And that means all ships contribute regardless of whether they use the infrastructure or not. And that spreads the investment costs for building out shore power and reduces the cost of using shore power. And hopefully it makes it easier for ship owners to choose the green option. At the same time, or shortly after, we have introduced other strong incentives. Cargo ships that use shore power in Port of Oslo receive a 20% discount on port fees. And zero emission vessels, they receive 100% discount. And cruise ships that do not connect are penalized through environmental scoring. But to reach our climate targets, shore power is not alone enough. We also need more zero emission vessels. And that's why we are working on green corridors. As you can see on the upper picture here, we have the vessel that will be run on liquid hydrogen that will go from between Rotterdam and Oslo and some ports on the way. And we are now exploring how to bunker liquid hydrogen in our port while doing cargo handling at the same time. So that is something we are exploring now. On the other picture here, we have, I think Hanno mentioned electric feeder container ships. This is Oslo. It's a ship owner coming from the Oslo area that has received support for building 2 zero emission ships that will run on batteries. Each container feeder vessels will have about 700-800 TEUs and a battery pack of 100 megawatt hours. And their thinking is that based on the regulations, we can connect to low voltage and high voltage shore power. But to really charge those batteries, they prefer connecting to high voltage shore power and charging with 8 or 7.5 megawatt hours. And container ships, they stay quite a long time in the port, so that will be enough time to sail emission-free between Oslo and Hamburg on one charge. But they haven't done the investment decision yet, and hopefully they will do it next week or before the summer. Just after the summer, in August, we will also have a fully electric bulk ship sailing in the Oslo Fjord with sand and gravel to our port. They will also charge by using shore power systems. Our fourth lesson is utilization. When we do emission mapping and see how effective these shore power projects are, utilization becomes quite important. It's really important that the cruise ships connect fast and stay connected the entire port stay. If you have a port stay of 10 hours or 12 hours and a ship use 1 hour to connect or more and disconnect a couple of hours before departure, you don't really get the emission reduction impact. And also it's not good for business either. So having a high focus on utilization is important. And this is not a technical issue. This is more an operational issue. So this is something we have a close dialogue with the ship companies on that. We would like them to connect as fast as possible, and hopefully the first thing you do, and that they stay connected for the entire port stay. We see that it becomes better, but that is a big variation between the different ships. Another part of utilization is about maximizing grid capacity. We need more grid capacity to the Port of Oslo. But we also need to use the capacity we have a lot better. In Oslo, we have built a lot of shared charging for our customers and for heavy transport. We started in 2023 with 6 public chargers for heavy-duty trucks. And now, by the end of 2025, we have 41 chargers for heavy-duty trucks. We also have combined for one project, we also have combined charging for trucks with shore power infrastructure. So this improves both economics and also grid tariffs and so forth. So the fifth lesson, last lesson, is about moving from separate infrastructure projects to a more integrated energy system. And on the picture on the right here, you can see all the projects we have built and are in design phase. And we're looking at how to more integrate all these systems. We need to look at consumption, storage, and flexibility together. And batteries play an important role here. They can help manage peak demand and also optimize energy use. And in addition, they create new revenue opportunities through flexibility markets. And this is what we're currently testing in Oslo. We have just received 2 big battery packs of 2 MWh that will be placed different places to kind of not compensate the shore power, but compensate all the other peak loads that can enable more grid capacity. So now I'm on my last slide. Let me just conclude with the 5 lessons. We have been building projects and we have learned along the way, and we have seen that starting with clear targets and good data has been really important. We have built before demand is fully there. The future is it's getting more and more obvious that the future is electric, and demand is just a time. It's just about time. And looking at fair business models and strong incentives is also an important aspect when we build projects. Utilization is really important, and looking at all the projects into one big energy system to use the capacity better. So I think that the last takeaway is that we have built a lot of infrastructure, and it's not about how much infrastructure you build, but how much we are getting it being used. So that is where we can actually reduce emissions, and that is our big focus area now on the optimization of the port energy system. Thank you.
Thank you. It was another great presentation. Thanks a lot. I believe we are slightly beyond the time of this webinar, but we would like still to have a discussion related to the polls. So I ask the administrator to put the results of the polls into the screen. The first question was, what is the primary driver for your organization to consider shore power? There we see at a large distance from the second answer that regulatory compliance is a number one requirement, followed by emissions reduction targets. Is there any comment from the audience or something that it was expected indeed? Can Jens give a comment?
No, it seems like a good mix, and I think all of them are quite relevant compared to the different segments. Regulatory compliance is important for some of the ship segments. For us, it started with the emission reduction targets. Mm-hmm. Sometimes the customers has actually asked for shore power, but usually it's something that we have to try to get them to use. But I think for us, it's really important to get more ship types into the regulations as well, because we see that on the bulk ship that the connection is much lower than, for example, for cruise or for ferries.
Yes. But by the way, this is one of the questions from the audience. Is there any known plan related to the other types vessels beyond container ships and passenger vessels regarding the application of the legislation for OPS?
I can maybe answer that
Yes.
one quickly. So the tanker was the obvious one on it. It's already in the joint working group in IEC in kind of a production, and then there is also what they call the general vessel standard, which is a very, let's say, flexible standard that can be used for kind of the various vessel types. So it will be addressed in this kind of a general vessel standard.
Thank you very much. Thank you. Let us move to the second polls. This is related to the biggest obstacle to wider shore power adoption. And then we see quite a few actually answers being very close to each other. Among others, the high cost, lack of port infrastructure. Actually, sorry, the lack of port infrastructure and limited availability of compatible berths. If we add them together, this is more than 60% of the total. Is there any reaction from the presenters? Can we ask Hanno to comment?
Well, again, depends a little bit probably which segment you're in and if you're demand side or supply side in the game. But yes, I know that many ports are still struggling to build the infrastructure, and so yeah, I can understand that, and yeah, and that it's not a cheap exercise as well. makes a lot of sense.
Yes.
And then basically driving the return on investment, yes. But I believe that come 2030, when the relation is actually starting, there should be a business case, and then you should see like no more lack of infrastructure, and that will actually lower the cost for everybody that's doing it, because I mean scale is driving down cost.
Yes, thank you. Can we move to the third question? And this is related to the factor which is most influencing the financial viability of shore power for the fleet. And then we see electricity pricing. Actually, number one is capital expenditure by 33%, followed by electricity pricing and the carbon compliance cost. And fuel savings and port fees and incentives are slightly below the others. Any comment?
Well, I think that the important thing of that to reduce this influence is to prepare the vessel from the very first moment. Because when you prepare a vessel from the very first moment in the shipyard, you can save a lot, including the OPS in the project. And fortunately, nowadays, nearly all the vessels are coming out from the shipyard like this. And the other thing is trying to get a project more, let's say, a standard for the vessels in order to reduce this capex for retrofit and for the equipment and so on. Well, I think if we can also see from the naval point of view, we can also save, and we have also room for improvement.
Yes, and actually this is an interesting point. As I tried to show in my slides, 50 to 60% of the new builds is currently equipped with equipment for onshore power connection. However, this means that another 50% is not. Still, okay, it's a significant percent, but it needs to be further increasing. I would expect that all the new vessels are built with onshore power connectivity. Okay, are there any other comments? If not, we are moving to slide number 4. And then it's this issue of the time frame, which indicates actually what we've been expecting, that people see the time frame of 5 to 10 years. 10 years has 37%, and 5 years has 25%. Actually, this people see that onshore power is coming, but to consider it as a standard practice, it needs some more time ahead of us. Any comments? Is it expected? Markus, do you like to comment?
Yeah, I can comment. Of course, in a question like this, it would be good to understand that who has responded. I mean, are they,
Yes.
people from Europe
Yes.
And I think in Europe and TEN-T terminals, the answers would be a bit different. But then looking at this globally and the speed of the regulation and that those areas of the globe, I think this 10 years kind of makes sense. I understand it.
Yeah, and it is within 10 years. Actually, I believe might be in agreement with general expectations. Yeah. Okay. Can you make a short round, starting from you, Martin? Is there any conclusion from your side that you would like to bring forward? Any concluding remark?
I would just say that from the technology perspective and also looking at the answers, was it on the previous poll, that the technology is mature, so that is not really the big issue. We have issues with the initial investment and building a business case and having power from the grid. So those are the problems. But from ABB's perspective, the technology is there and will be further developed. So that's
Okay.
my final comment.
Will we ready by 2030, at least at the ports which are required to have the OPS available? Is the time frame sufficient to be ready by 2030?
Yeah, I doubt a little bit, but also I think that the ambition level is now there. I mean, we see a lot of projects in Europe at the moment, so
Yes.
there seems to be genuine ambition to complete by 2030, but it will be very tight. Yeah.
Okay. Yeah. Mr. Hano, any concluding observations from your side, please?
Yeah, I also think, as Markus just said, I mean, we are in a mature technology now, so we've collectively gained a lot of experience in this, and shore power is here to stay. And I see there's lots of opportunities in terms of battery charging. So I only encourage everybody to get ready if they haven't done it, or start with it. 2030 is approaching soon, and those who haven't started yet, I mean, they probably get into quite a rush at the end of the day. And as I say, I mean, collaboration is important, and everybody, I think, is happy to share experience to help others.
Yes. Anna, any concluding remarks from your side, please?
Well, just in order not to repeat, but I think the operational experience that all of us are achieving are key to develop better projects, and cooperation to share this experience are important to moving forward. 2030 is just tomorrow, and we need to cooperate and just to continue doing things. It's not possible just to wait. We have to work.
Exactly. And Jens Erik,
Yeah.
from your side?
I think one big topic for ports that have not yet built shore power is the collaboration part, that the power requirement, as Anna showed, that the power requirement for really big container ships is quite small compared to what you thought, and that means that you can maybe get to connect several ships on just one shore power system based on how you design it. So collaboration, we learn a lot from Gothenburg on tanker projects, on other projects. So I think that is a big part of reducing costs. And I also think that the prices for using shore power will be dropped significantly when we get a higher utilization and usage of the shore power systems. And something that we are working on is to get more ship types into the regulations also. Why shouldn't bulk ships be into the regulations? Why shouldn't ro-ro and so forth?
Well, I'd like also to thank you that you have answered the open questions where it was obviously that an answer from your side was required, Jens Erik. We will review the questions to see if there are any critical open questions that provide an answer to those involved, but I believe we covered at least 80% of the questions answered. We managed as a team to give some good answers. We have also indicated that there are quite a few issues open and a few challenges in front of us. I would like to thank you for contributing. I'm apologizing for the small delay of 20 minutes. This is for any big project and also for any big presentation, any big discussion. A small delay might be, excused, taking into account the subject. Many thanks. Have a nice continuation of the day, wherever you are, and I hope that this was a useful 2 hour, almost 2 hour event. Thank you very much. Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye. Bye-bye.